Hi, welcome to the start of a series of tutorials on C++ handling files. We're going to start with input file streams, right? How do we read information in from a file? And what we're going to use is the class ifstream, so input file stream, that's defined in the standard namespace of C++. I've got my favorite, one of my favorite websites here, cplus.com, using their reference pages. Got this up here. And the library where this class is defined is the ifstream or the file stream library. And so over here in some code, I've included the ifstream library. And we're going to create an object of that type. So the type is ifstream. Right? It's defined in the standard namespace. So I've scoped it with std : and we can follow the C++ identifier naming rules for naming this object. A lot of people call it in. And I'm just going to call it in file as the name of the object. And I've got a comment here saying that we're going to create an ifstream object using the default constructor. But I don't know if you're familiar with classes, then you understand what a constructor is. But if you haven't yet studied how to create a class in C++, a constructor is a function that's automatically called whenever we declare an object of its type. And so in this case, when I just gave it a name, it calls the default constructor. If I want to call any other constructor, normally I have to pass information. It looks more like a function call where we have parentheses and some information in here. We'll see how to do that in a second. But so what I'm saying is if I declare an object right of this type and I don't have the parentheses after it, it uses the default constructor. And every class should have a default constructor defined. So here, this just tells us it's going to create an ifstream object that's not associated with any file. Notice we haven't given any file names yet. We'll have to do that soon, right? And it will also then associate, ifstream is built on top of istream. So it'll call what the documentation is saying here is this base constructor, and it'll be given a pointer to a newly constructed file buff object, right? So a file buff object is associated with this stream so that when we open a file, what this is saying is we'll have access to the file contents. It will be pointing to the start of the file in the way we're going to open it. We won't have to worry about manipulating pointers. We are actually going to use the extraction operator to read information from the file. So not really exciting. Right, we created this. When we create it and use the default constructor, what we'd like to do is we would like to open a file. And so if we go back here to where this class is defined, one of its members is open. And so that actually opens a file. If we were to open a link in that and read about the documentation, right, it tells us that we can pass some arguments for name of the file and the mode that we want. One of the things I like about this website is it tends to give you examples, right, that are easy to follow, easy to copy. In this case, you can run right here. You can run this and see what the output is. What we'll do is, right, we're going to call the open function and pass it a file name. In our code, so in file, we use the name of our object. When we call the member function, we use the dot operator to do that. The member function is named open, and we'll pass it a file name. So that was calling it test.txt. We'll call ours .txt. And we're going to open text files. So these are files that you could open with any sort of text editor and read what's in the file. C++ will work with text files, and it also works with binary files. Binary files are just filled with zeros and ones, and you have to have an editor that's capable of opening one of those to actually open it and see the zeros and ones. But it's usually not meaningful when you're looking at those zeros and ones. So we're going to work with text-based information in these tutorials. Later, I will do a tutorial on working with binary files that contain binary data. Right, so we give it the name of the file to open. And then if we tell it we want it to open it for input, standard ifstream, and then in. Now, you can leave off this argument because when you're using an input file stream, ifstream, typically we're going to open that to read information or for input. And so if you leave out this argument, this is actually the default mode it will open in. So it will open and allow you to read from the file. So we'll get input from the file. So when I say read from the file, we input data into our program from the file. If we want to write to a file, we open that in an output mode or a write mode to write out to the file. But here we're opening this up to try and read something in. Right. Now, what we'd like to know is whether or not this successfully opened our file. And so one of the things we can look at then that's associated with this object and this is the file stream bits. So it actually keeps track of, so you can see the return value is none. The function doesn't return anything, so we can't capture any information. But what we can do is we can look at the state flag. So for this ifstream object, we can look at its state flag to see whether or not it successfully opened the file. Right. And there's different flags we can look at. Let me. All right, so the state of the file, so for error states, right, it keeps track of good, end of file, EOF, fail, and bad. Right? And it also has another operator as well that's been defined. So the not operator as well will evaluate the stream and return some information about its condition. Right? So if we want to see if we successfully opened our file, I'm going to say if. One way we can do it is say if not in file. And what happens is if it was not able to open the file, this condition will be true. So in file, if this is a false state or bad state, not false makes this true. So that's why we say not in file if it failed. And in that case, I'm just going to output some information, fail to open file. And we're not going to do anything else in our program at this point, but we just want to see if this works. And I'm working in a directory here called tutorial. And if I list what's in that directory, I have an executable. Let's remove that. So let's list this again. The only thing here is this program example 1.cpp. And so if we want to go ahead and build this, and now if I list that, it made my default executable a.out. So if we just run this, what we should see is an error message, failed to open file, because our program is looking in the very same directory, because when we put the file name here in double parentheses, this has to be a string data type, the name of the file. It's going to look in the very same directory where our C++ file is. And notice then when I listed this, right, we don't have a file named test.txt here. This is why it failed. Now, if I were to create a file called test.txt, so I could create basically an empty file, test.txt, with a touch command, right? And now if we list what's in the directory, we can see we have a file, test.txt here. Right? And so now if we run our executable, we do not see that error message. It actually opened the file. Right? After we successfully open a file, well, we're opening this one to read data from. And one of the things we want to do before our program quits, when we're done with the file, is we should close the file. And I don't have any code in here closing the file. If we want to close a file, we simply use the object name in file, and we call the close method or member function. And we don't have to pass it the name of the file because the name of the file is already associated with our object. When we open this file back here, it knows what file that this object is associated with. So when we close it, that will close its association from the file. We can't read to it anymore, right? And if we were to just rebuild and rerun, we shouldn't see any difference, right? But this time it did close the file for me. Okay, that is one way then to open a file. Now, there's some file stream flags that I mentioned that we can check, these state flags. The good, the end of EOF, the fail, and the bad. And actually, these actually just return, I believe, zeros and ones, right? So here's this, so zeros and ones, Boolean. So here is the good function, right? Its return data type is bool, function's name is good, and so if we call it, right, it should return true if it's in a good state, and that's what it tells us down here with a return value true if none of the stream's state flags are set, false if any of the stream state flags are set, like bad bit, end of file bit, or fail bit. And so actually then, this is showing you here, you can actually print out the state of these flags. Right, so they've written a function to do that. I'm actually just here going to print out the states. So if we want to say, well, what is the good function return? So in file dot good. The Boolean, it will convert, I believe, to an integer when it prints. 1 should be true, 0 should be false, and just right. And I've included the ifstream library in here because I knew I wanted to use cout. And so we can print out the values of the other flags. Now we would expect, right, if our stream's in a good state, that will return true. So our others are EOF for end of file, fail, and bad was the other flag, I believe. So if we're able to successfully open our file, and we're not reading anything from it, I don't think the EOF flag will be set, fail won't be set, and bad won't be set. All right, so let's recompile. Let's rerun our executable. And down here, we're seeing good has a value of 1, end of file has a value of 0, meaning it was false, fail was false, and bad was false. So those are streams that you can check as well too, instead of saying not in file. As a matter of fact, let's see what happens if we change this and say if in file dot fail, we wouldn't expect this to fail to open it because our file exists. Now let's recompile. Let's rerun. Right. This message didn't print out, so it didn't fail. Right. We can see the stream states. Now let's get rid of that test.txt. So if we remove test.txt, right, list what's in our directory, notice it's gone. I don't need to rebuild the file or rebuild the executable. Let's run the executable. And notice we get the fail to open file. Notice the good function now returns a 0. It's not in a good state. It's not at end of file. It's not in a bad state, but it is in a fail state. So that's another thing we can check. After we try to open it, we could use the exclamation mark, not in file, or we can check in file.fail, right, to make sure it didn't fail to open. Right. So I'm going to end this tutorial here in terms of, opening a file. Wait, I lied. I said I was going to end it. The other thing I wanted to show you is if we don't use infile.open to open the file here, right, we can use the other constructor, which here, the initialization constructor, right? That initialization constructor, we can pass it the name of a file. So here, let's pass it the name of a file. You don't have to leave a space. And I'm going to call this one data.txt. We could use test.txt as well. This one does not exist. If we don't tell it to open it for input, it will by default open it for input. So let's rebuild here. And let's rerun our executable. Right. It failed to open our file because data.txt doesn't exist. Notice the fail flag was set to 1. So it did fail. 1 is true. So if infile.fail, it printed out our error message. Now, actually, if this failed to open, what I should be doing is leaving the program here, not trying to close the file. So here I could just go ahead and say return 1. I shouldn't drop down and try to close the file if it doesn't exist. Notice it didn't make the program crash, but it would fail to close the file. And just to show that, well, it won't show, if I rebuild, it won't show it not calling fail, but it will just return right away. I don't know that that's really useful. All right. Now let's go ahead and create a file. Now I'm just going to, again, just use the touch command, data.txt. Now we'll list that file exists. So now if we run our executable a.out, txt exists, right? So we're in a good state. And right, we're not in a fail state. We didn't see our message. So it opened our file and closed our file for us. So 2 ways you can open the file, right? Using then, we were using, in this case, the initialization constructor. The other case would be in file 1, in file 1 dot open, and the name of our file. 2 different ways to open a file. Check to make sure that it opened correctly. If it doesn't, all this program needed to do was just terminate at that point. If it did, we want to make sure we properly close our file. So in the next tutorial, we will actually then start reading data in from a file. So I hope you found this helpful, right, on how to open a file correctly and check. See you in the next tutorial.